And welcome back everyone to part 2 of our second reactions lecture. Right now I'm going to go over the different symbols that we're going to be using in stoichiometric reactions and elementary steps, representations of reactions, laws of definitive proportions. Now, just to give you guys a brief description of why I'm doing this, it's really important that you nail down these basics and this nomenclature and these symbols just so that you don't get confused along the course. So let's just get started. So you can read from this list the different steps in stoichiometric reactions and how they're represented in terms of symbols. For example, an irreversible reaction, that is one way. That's also stoichiometric reaction, i.e. not an elementary reaction. Remember from the last video, an elementary reaction is more like something that is unstable in the sense that it will go towards completion and doesn't stay there that long, like doesn't have that reaction for that long. So here's the stoichiometric reaction that is irreversible, and the elementary one is basically the same thing except it has one line less for the arrow. And then this is the same case for reversible, equilibrated, and rate determining steps. Now, representations of reactions. Now, this is just an example of how this is applied. You can see over here that your overall reaction, which is your stoichiometric reaction, has these two equal signs, and let's see what this means over here. This means that it is a reversible stoichiometric reaction. Now, as for the elementary step, it is, as you can see, just a straight line. And you just add these two so that you can have the overall reaction. And yeah, so in terms of when you're actually drawing your rice table, Michael Rizzo went over that previously. You have to understand that in this equation for how you represent reactions and when you're adding them up, products have a positive stoichiometric coefficient while reactants have a negative stoichiometric coefficient. Now, law of definitive proportions, this basically means we're solving for the extent of reaction, and remember the extent of reaction is basically how far the reaction has gone so that it could reach completion, and solving it over here, you do that by taking your moles at a certain time minus your initial moles over your stoichiometric coefficient. Now there's going to be one third and final part for this introduction video, so please stay tuned. Thank you.